Hey, Sean, do you know what? I think that our listener want real protection against cyber risk, and I know that High Trust is the leader in cybersecurity assurance. But what makes them the go-to choice?
Well, according to our friends at HITRUST, because their framework covers 100% of the known tactics, techniques, and procedures, in 2024, organizations with a HITRUST certification had just a 0.59% incident rate, meaning 99.41 stayed breach-free.
That's solid, but what about staying sharp over time?
HITRUST regular certification process isn't just a checkbox, it actually drives improvement. Repeat customers see up to 54% fewer corrective actions needed year over year. And now, with their new AI security assessment and certification, you can actually tackle AI risk with confidence as well.
Then check out the iTrust framework. Go to hightrustalliance.net to learn more.
Marco,
Sean,
don't look so surprised.
I am surprised.
Surprised
Actually,
that I actually made it?
no. I know you're already in Europe, and I'm already kind of making my own plan for when we're gonna be in London. I'm wondering where are we gonna, you know, where are we gonna go and turn on the camera and do something stupid or talk about interesting topic. I'm thinking
I like
I want to
being
go
stupid
back
in
to
London.
Abbey Road this year
Abbey,
and
Abbey Road
do
would be
the
good.
second take that we
Second
did
take
last
in
year.
Abbey Road. I think the Marshall factory would be cool. I haven't organized that yet. I'll have to do that
All
this
right.
week. But
Well,
anyway,
still music related, so
it
I'm
is
good with
music
that.
related.
It's good to get some music because our days are going to be filled with technology and cybersecurity. Obviously, this is a pre-event coverage of our presence in London at InfoSecurity Europe. So, we try to sprinkle a little bit of what else ITSP Magazine represent, which is technology and society as well. So
Right.
we cover everything, cybersecurity, technology, and
And
society.
I have a podcast on music and technology,
There
which
you
is
go.
why that topic keeps coming up. And funny enough, enough people in the industry, so it seems many people play
Yeah.
and either play or create music or connected to it in some way, which is quite incredible. I'll just throw this out there. Peter Garraghan, how are you?
Hello, I'm great. How are you?
Very good. It's good to have you on. Are you? I don't know. Do you play Bowron in the pub sometimes when you're in Ireland?
If I have time to go to the pub, yes. I do play instruments, typically in the
There you go.
rooms of my own home.
See, it
There you
always
go.
comes back. There's always music somewhere.
There is.
I love it. I love
For
it.
sure.
All right, so
But we're not here
talking
to
about
talk
music
about
today.
that.
We're not here.
Although AI, it's involved in music too.
It's
I
gonna.
don't know about that part, but okay,
Yeah.
let's move on.
Well, that's a different conversation. But certainly AI is used in a lot of things in business. And so Peter has a session on at InfoSecurity Europe called "Can My AI Be Hacked?" And yeah, an intriguing question, of course, and excited to hear your take on all this and maybe tease out your session a little bit, Peter. But before we get into answering that question or teasing that question, because we want people to join you at the session, maybe a few words about some of the things you're up to at the university and what you do on a day-to-day basis as well.
Sure, sounds good. So, I'm Peter. I am a chair professor in computer science at Lancaster University in the UK. I'm also a fellow of the Engineering Physical Science Research Council in the UK, which are a set of consulting fellows who specialize in certain areas of research in the UK. I also operate a university spin-out company called Mindgard. It's a startup in London that specializes in security for AI. I spent about a decade looking at cybersecurity issues within computing systems that use AI, so deep neural networks, looking at compiler security, network security, application security within AI.
And then let me start with this question, because I mean with the launch and uptake of ChatGPT, that there's no question that AI has gotten a lot of attention from the media and from organizations all over the globe. But clearly AI and machine learning underneath that has been around for quite some time. And so you just mentioned 10 years you've been looking at this. What's the delta in terms of capabilities? Maybe remove the graphical interface that most people have access to now. But what are some of the biggest differences in the models and the use of AI and machine learning and all the other stuff that you've seen over the past few years?
Sure. This is a whole research lecture about the history of AI and machine learning. I think to be quite succinct about it, it is still software, and that's no different from what we had for many, many years. And we're going to have the problems and the benefits of doing so. But I think the easiest way to think about AI nowadays, what they really mean are deep neural networks, which is a type of architecture that back in 2014 was shown to actually outperform a lot of other type of machine algorithm techniques. And then fast forward to today, people hear about AI in terms of ChatGPT and large language models. I'll go into shortly probably about a quick analogy of history. It's really important, but fundamentally, what's different about nowadays AI, and true for all types that there's much more focus on generative AI, things that generate content, so generate words, predict words, and generate images. We've had predictive AI for many, many decades, being practitioners. Regression algorithms, linear regression is type of AI in the system. So one of the big differences now is that, yes, it's become pervasive, ubiquitous, and it has to become commoditized enough that the everyday person can now use it, as opposed to me downloading a library and trying to figure out how on earth do I do training, how on earth do I do my test training split. Now it's being kind of empowered by the users themselves to do the system. I think maybe to set the scene, I like to give an analogy of what happened in another technology where we are now. So cloud computing, I don't think people are going to deny cloud computing actually is pretty big nowadays, both from a market and it's used everything. Even this call, probably using the cloud to do so. The core technology that powered cloud is virtualization. Virtualization was actually invented in like the early 60s. The IBM mainframe machines could do virtualize, but they had 2 megabytes or megabits of memory. And they're saying, well, we haven't got memory, it's too expensive. Interesting. It wasn't until the x86 architecture was virtualized and memory became cheap enough, they say, okay, now critical mass, now we actually can scale this out and spin up machines and kind of have this scalability. And the cloud computing industry kind of really accelerated. Now it's everywhere. And all the pains in doing so as well. And we'll talk about security, but the house has security problems as well. Think of AI. The artificial neural network was invented quite a few decades ago. It wasn't until in 2014 that they could demonstrate that, yes, it could outperform other type of ML techniques. And it became cheap enough and scalable enough to get this thing trained on lots of internet data. In 2017, the paper All You Need Is Attention came out from Google Research, and that is the transformer architecture that underpins all type of LLMs and even what you call agents. And now it's flourishing. And it'll give it a few years' time, lots of hype about this space. Fundamentally, it'll become a very good technology underpinning things, but following exactly the same history and life cycle that you see in virtualization. That's a few decades to get where we are now. We think of AI modern nowadays, it's following a very similar trajectory.
Well, that was a nice history overview.
Very cool.
And it connects to what I always think and point out when I talk about technology and society is you need the convergence of different technology and also the cultural mindset that can actually then spark that tipping point, and as you said, it becomes it reaches that critical mass where things are good. But obviously, we're talking about cybersecurity here, so among all the amazing things that can be a lot of good for us, well, those can be discussed as well, but we're not going psychological here. It comes with a lot of risk, and so why don't you tell us that part of that story?
So, not saying to be contrarian about it, but I spend a lot of time as a scientist trying to have an empirical view on things, or even trying to find something. I hypothesis, I test it. Does AI models have risk? Yes, but the risks are no more serious than any other type of risk in cybersecurity. The difference here is that people don't understand it as much as they should do. People have a habit of anthropomorphizing AI. It's not our fault. It's speculative fiction. It's human nature to do so. Mm-hmm. I haven't seen a new attack come from AI that you cannot see grounding in other types of cybersecurity attacks. And that's a good thing. We've been doing these type of things for many, many decades. So what type of risks in a model? Well, an AI model can do things such as it can generate bad output. That output could be information, or it could be instructions, commands to another system that will cause problems of mark and rejection attack or data infiltration attacks if I do instruction set. I can inject bad code into the model itself and the artifact, and if it's opened up, I'm going to have a vulnerability in my organization. It can even range from, if the area is being used for detection, I can bypass and basically find blind spots. And for those who are security experts, this is not new source. We've been doing this for many, many years, but the difference with the AI is how you do it is different. So there's lots of analogies between SQL injection and problem injection. We've been claiming SQL injection has been solved for decades, but it still happens all the time. Problem injection has a lot of analogies, but how you actually do it is quite different. Two reasons. One is the problem with prompt injection is that the data and control plane and LLMs are the same thing. There's no separation, and that is problematic. The guys in Anthropic and Google tried, and they kind of abandoned it pretty quickly because it was too hard to do. I'm sure they will fix it at some point. And also means that the amount of combinations of instructions you could give and outputs is near infinite. And you're basically trying to rustle an API with natural language, and that's very, very complicated. So when you think of risks of models, I always say to people I talk to, whether it's governments, which I support, but also people I work with and scientists and even customers, replace the word AI with software and ask questions like, what's my risk? The answer is yes, there is a risk. The difference is there are some nuances in new technology. And maybe the last example I give you is, given the AI itself is intrinsically opaque and stochastic, it's very, very random, but I can't do code level SAST on a neural network. It's a bunch of matrices and numbers. I can't actually look at that code. So when a new tech comes out like AI, you have to think about how do my current controls apply and risks apply, and they do apply. The risks are still the same, the height matters differently. You need to update tooling, update training, and update playbooks. And every time this comes out, I think one of the problems is that because it's AI and people have very big claims and imagination of AI, I think they sometimes forget actually cybersecurity attacks in computing systems and data security still apply, but how they work in AI is slightly different.
So I'm going to ask you this because it's been a topic. Debate might even. I certainly haven't argued this. I've certainly had some debates, which may be a little strong, but definitely conversations around this idea of you use the word infinite, you use the word opaque, and to me, when I think of AI and the systems that are built around it, you create a world that's very hard to contain. Very hard to describe. Here's what I expect it to do, here's what I expect it not to do, and I can kind of box that in and wrap my risk modeling around that in traditional software. When you drop the AI and the models in there and agents and all kinds of stuff, it seems to get unwieldy. And so the debate has been, is it, to your point, is it really just software? Or do we need to treat it differently? With respect to how we manage risk and put our controls in place and write policies around it. So your thoughts on all of that?
Sure. So one of the biggest differences is that the interfaces we communicate with AI is more natural language-esque as opposed to very rigid protocol-esque, and that introduces some confusion. But from my experiences, a lot of the attacks, I'm still relying on my experience of cybersecurity, system security, pen testing and red teaming, but I need to figure out, in this case, I need to use certain different tactics. We talk about socially engineering the LLM to do things. What I'm really doing is doing, perturbations of prompt injection to find an instruction I want, which I can also do by fuzzing. That's the same analogy of that system. I think one of the important things in this space is if we take a step back and think about software and AI, people have a habit, again, of anthropomorphizing, just throwing out basic AppSec principles that apply to AI. So actually, a lot of problems could be fixed by just taking it seriously. But to your point at the beginning about how we build applications and systems. So normally, how we build these things is we start with nothing. We define a use case. We do an architecture. We think about the non-functional functional properties. We think of threat modeling. And we start building out our capabilities. Every time we add a new function or functional property, then we figure out, okay, this is actually good. So over time, the system gets more complicated, and eventually you'll miss something, and a security breach happens. So you're kind of building from the ground up, bottom up, build systems. And that's for fault tolerance, that's for security. The problem with AI, though, is that you're putting in a software component that's crammed full of stuff you don't need. I have a component, let's say I have an application generate, all I wanted to do is write emails to me. That's what I want to do. I download a piece of software that can write songs, can write poetry, can do encoding, can do different languages. If I took a step back and said, I'm going to build an app from the ground up, I've crammed in 50 features I don't need, my product manager will say to me, why are you doing this? Because not only is it a waste of my time, but also you're introducing a huge bunch of new risks that I have to go test. So the difference here I've seen is Instead of starting from very basic and building things up and starting your testing and threat modeling, you're taking this huge thing that has things you don't need and trying to cram it and trying to squeeze it into things you need. And that's one of the differences I've seen in terms of like looking at risks within AI systems. You've got 9 of the stuff you don't need, and then the attack can get that out of the system and cause problems.
Right. Does agentic AI maybe help in that sense, where you're purpose building and maybe blocking stuff?
Sure. So again, to cut through the hype and market in this space, software agents are a new concept. We've had software agents for like 20 years, 25 years. We've had RESTful services. So as an architect, it's been a long time. The difference now is that we can put transformer architectures within software agents. And now instead of having very well-defined APIs that I have to test for SOAP or REST, it's using natural language. That makes it much more complicated. But fundamentally, the attacks are still the same. I was at B-Sides and RSA, a lot of discussions about agentic AI security. And I looked at the architecture thinking, they just slapped the word agentic in front of everything. Agentic prompt injection, agentic evasion, agentic poisoning. I was like, actually, what is the difference here? It's still a transformer, it's still capability. So actually the techniques and attacks are the same, but the difference is the use case is slightly different. So in agents, we typically talk about action. So agents are a strategy to do action. So I give the analogy of a bus and an F1 car are the same thing in principle. They have engines, they have wheels, they have 4 of them, I hope. But the type of attacks and threats you're going to prioritize are different. So in agents or agentic workflows, you're also going to use attacks, but they'll be specialized against it versus an agent system or AI model system attacks. You prioritize different type of risks and threats based off this. But the difference really agents is software agents are a new concept, but with the use of natural language and the use of agents is to do action. The type of things you worry about, like tool calling or instructions to other tools, becomes much more of a threat versus my LLM that's in my local machine with no internet access. The threat modeling and attack surface is very, very different.
Wow, I think this could be easily a 45 minutes to an hour conversation, because I mean,
hence the session.
Let's get to the session, and again, I mean, this is something we should definitely go deeper into, because I feel like we're just going the wrong direction, as we often do, because marketing also. Let's just add stuff to it. Then eventually we will remove it. We hype what we can do and what we cannot do instead of be careful. So tell me a little bit more about where are you going to focus amongst all of this in your presentation?
Sure. So I'm presenting InfoSecurity Europe. That will be on the 4th of June. And I think it's on the cyber strategy stage, about 425, I think. Can the model AI be hacked? The answer is yes. Facts are coming, but no, seriously, you should come along and I will explain why it is and actually what is nuanced about it. I think the main takeaway is that as a cybersecurity practitioner, a lot of your skill sets will apply. You understand things conceptually. The techniques are different. And I want to try and explain that to why is it different and how is it the same. And we've been through this before. We've seen a new tech comes out, and the analogy I give people is, think of a giant sieve full of flour. When a new tech comes out, people claim to do everything. Virtual cloud could do everything. Everything should be cloudified. It'll make everything great. What we did is we got a sieve and shuffled it. A few pieces stayed, and each of those pieces became billions and billion-dollar industries. And we focused the threats on it because they're serious. In the world of AI, people are claiming it does everything. And you shuffle the sieve, 3 or 4, maybe 6 things will come out, and they'll be worth a lot of money. But what I want to do in this space in my presentation is talk about what are the type of actual risks that I see on the day-to-day basis and attacks that we launch and we find from research in the company, talk about the grounding of why it happens, and kind of give reassurance by saying that if you're a cybersecurity practitioner, it's not magic, it's still software, but you need to update your training tools and playbook. And I will try to give some actual examples, because the other problem in this space is people talk very conceptually about problems. They don't actually give you a lot of systems level problems. Here's actual attack we can show off. So hoping the presentation I could demystify some of the concepts, actually show what's happening on the ground today.
And who are you speaking to there? Because clearly there's cybersecurity operations, which you can have endpoint management, network management, data management, and protections around all that. Then you have the detection team, and then the response team, perhaps, and the SOC. And then you have the rest of the business who, by the way, can deploy all this stuff without including security. So are you speaking to practitioners in security? Are you speaking to line of business owners? Who's the best target for what you're presenting?
And I speak to pretty much everybody, I think, in this space, because again, people get their imaginations captured by AI and kind of actually overlook pretty common problems that in terms of risk. So let's pick a random example. So think of guardrails. That is a very common phrase, because I'll use a guardrail, it's fine. But you say to them, would you rely on a web application firewall or WAF security organization? Saying, no, that's a silly idea. So, well, same thing for AI. You can't just slap a guardrail and say it's okay. There's a whole bunch of other problems involved from a system security, risk compliance, there's a whole bunch of issues about that. When I talk to data scientists who love getting AI to do high performance, high quality things, not only trained in risks, they think about risks and societal risks. I actually say to them, actually, I can use this to do market injection, and then like connect to a system, that's all a problem. I didn't think about that. When I talk to business leaders about this, I say to them, take a step back and say you have an asset that you can't evidence risk, you can't find vulnerabilities, you have no tooling, and you're kind of not applying your basic controls to this. Why are you doing this? And they think, okay, it actually makes sense now, I probably should be. So one thing I'm advocating strongly to them is take a step back, look at all your standards and current controls, whether it's in GRC, just governance risk compliance, or in security teams, even just app developers, and say to them, let's swap out the word AI with software or data and say, should I do X? The answer is probably no or yes. And I think that really helps them understand. But the problem in this space is that people are overselling some of their capabilities. And in some cases, it's fantastic. In some use cases, other cases, jury's still out there. It's a very nascent space still. And I'm hoping the ones who actually are getting AI into production, they are seeing real problems. And a lot of problems they see are they haven't applied basic controls of application development and or security controls. Some of them have done a great job, but then they're realizing then I haven't got the tooling or the know-how, so I'm an AI expert to actually address this.
Very cool. All right. Well, I'm going to say this, which is lately I like to say we go to these conferences because we look into the future. We go for the community. We also go to kind of maybe, hopefully, kind of remove what is talks and maybe focus on what the priority should be. And I think by putting together academics and vendors and technologists and talking about geopolitics, there's going to be a session about that. And, you put a lot of different minds together. And I think maybe we'll walk away with a little bit more of a clear picture of where we're standing in cybersecurity. So that's my hope. I think InfoSecurity Europe has been always doing a great job in doing this. I'm excited to be there. I'm excited to meet you in person, maybe even chat a little bit more. And for everybody that cannot be there, they should definitely follow us, Sean, on location. Not much for you, but for me.
itspmagazine.com/infosec25 is the URL. Can My AI Be Hacked is a session that Peter's going to be presenting again Wednesday, 4th of June, 4:25 in the afternoon. What is it? The cyber strategy stage. Look at that. And of course, we'll be there all week, covering the event, talking to keynote speakers, analysts, vendors as well. So we'll bring all the innovations, all the mindsets, all the thought leadership that you want from InfoSecurity Europe, London. And Peter, it's fantastic meeting you. Thanks for sharing your session with us today. Hopefully you fill the room and get a lot of interaction with folks. For me, it's about shedding light on what's new and removing the mystery and finding a path to take some steps forward to do things in a way that the business can grow and flourish and generate revenue, but then also in a way that we protect that revenue and growth. So thanks again.
Thanks, both.
And everybody listening and watching, thanks for joining us, and we'll see you on location. And do stay tuned, subscribe, share with your friends and enemies. We'll catch you all on the next one.
Hey, Sean, do you know what? I think that our listener want real protection against cyber risk, and I know that HITRUST is the leader in cybersecurity assurance. But what makes them the go-to choice?
Well, according to our friends at HITRUST, because their framework covers 100% of the known tactics, techniques, and procedures, in 2024, organizations with a HITRUST certification had just a 0.59% incident rate, meaning 99.41 stayed breach-free.
That's solid, but what about staying sharp over time?
HITRUST regular certification process isn't just a checkbox, it actually drives improvement. Repeat customers see up to 54% fewer corrective actions needed year over year. And now, with their new AI security assessment and certification, you can actually tackle AI risks with confidence as well.
Then check out the iTrust framework. Go to hightrustalliance.net to learn more.